Hello, welcome to Computer Science 1. This is CSCE 155E. I'm Dr. Chris Burke, and I'll be your instructor this year, or for this semester, I guess. Today we're just going to give a course introduction, and then I'm going to give you a brief preview of what you're going to be doing in your lab tomorrow. You're going to be getting set up, running your first Hello World program, checking some stuff out from GitHub. All right? So first of all, are you in the right class? Well, actually before that, I'm live streaming this lecture. All my lectures are live streamed on YouTube. They are available as recordings immediately afterwards. So just be aware that it is being recorded. This baffle will not pick up any of your voices, and unless you walk behind me, you're not going to be on camera. All right. So, but the recordings will be available. And I also make sure that the audio is working and we're good. All right. All right, so are we in the right class? Well, this is Computer Science 1 using C. It's a highly challenging and rigorous introduction to computer science. There are other offerings that the department makes. CSCE 101 is an introduction using Python, primarily for non-majors, and it's a terminal computing course. It would be the only computing course that you would take. 155A is the other version of this course that also uses Python, and it is a little bit of a gentler introduction to computing. And then 155T is also in Python, but that's for data science majors. So if you're looking into data science, then that might be the course for you. We also have 155H. Some of you are invited to that, but chose to either go in here or maybe it didn't work out for your schedule. But if you are interested in the honors version of this course, please speak to me after class. The honors version actually covers C and Java in parallel, two programming languages at once. And then for general engineering majors, they generally advise MATLAB 155N. Now, if you are robotics or if you are electrical engineering, then you're in the right place. They would not recommend MATLAB to you. They would recommend C. Right? It's okay, by the way, if you have prior experience. It is unlikely that, especially if you're coming from high school, that you have any C experience. And it's perfectly all right if you don't, because we are going to start from a basic Hello World program. We're going to start from scratch without any assumptions that you have another programming language already. Okay? So if you already have some prior experience, you're still going to learn something, because I highly doubt that you've learned C. All right, so I'm your instructor. I will be for the next semester. I also teach CS2 in the spring semester, so if you're continuing on in the program, computer science, computer engineering, you might also have me for spring. And then we have about, I think, maybe a dozen learning assistants, or TAs, for this course. You can learn all about us by going to the Getting Help and Instructor Info page, which is the very first link in Canvas. And there you will find a help hour grid. Right? This help hour grid, basically, it tells you when an LA will be available. All of these help hours are held in Avery 15. That's here in this building, in the basement, and it's down that hall. So if you go to the Math Resource Center, keep going, and that's Avery 15. It is a large lab. You can get in 24/7 with your N card. The building, you can get in 24/7, even on game days, although they recommend not doing it. In the south, that's south. In the south entrance, you can get in that way with your N card, as long as you are enrolled in a class that meets here. Right? Otherwise, they're my help hours. Right? I was there available from 10:30 to 11:30 today. But otherwise, if you need help afterwards, Emmanuel's down there. Right? You can pretty much find an LA throughout the week that will work with your schedule. Obviously, they're not going to hold help hours during the lab sessions or during the lecture, though. All right. You can learn all about us. We have a little bit of bios here and who's covering what, and you can find your LA. We've got their pictures there. All right. All right. So, what is this course about? It's computer science, right? It's the introduction to computer science. And I've got some quotes here from some authors that I enjoy. The first one is from Douglas Adams. He says that if you really want to understand something, the best way is to try to explain it to somebody else. That forces you to sort it out in your mind. That's really the essence of programming. Also, it's the essence of teaching. If you're able to teach something, then that means you probably really understand it, or you need to understand it in order to be able to teach it. By the time you've sorted out a complicated idea into little steps that even a stupid machine can deal with, you've certainly learned about something about it yourself. And that's the essence of problem solving. You take a complex problem and you break it down into smaller and smaller parts until you have one line of code that a dumb machine can actually execute. Right? Another one, in my experience, you assert control over a computer, show it who's boss by making it do something unique. That means programming it. If you devote a couple of hours to programming a new machine, you'll feel better about it afterwards. This is especially true in the age of AI. AI is only making computers and computing more of a magic to everybody, right? Wow, look at all this stuff it can do, right? That makes the machine the master of you, right? However, if you know how it works, if you're able to manipulate it, if you are able to, make yourself the master of the machine by making it do what you want, then you retain agency, right? You're still the human in the loop, right? Don't let AI take you over, basically. Right? Those two quotes go back a long time, and it's basically problem solving. Computers don't solve problems, even with AI. You do, right? Computers only automate solutions. That's exactly what AI is. It's automating solutions. Ours is a discipline that has become ancillary to all other disciplines. 5 years ago, everybody was saying everybody needs to learn how to code. If you're a marketing major, you need to learn how to code because you'll be using it in marketing. If you're such and such, if you're an artist, you need to know how to code to do this and this and this. That's probably no longer true. But this quote from Isaac Asimov over 60 years ago probably is. The world of tomorrow, they were asking 50 years in the future at the time, will have few routine jobs that cannot be done better by some machine than by any human being. Mankind, therefore, will have to become largely a race of machine tenders. Schools will have to be oriented in that direction, right? And so you need to learn how to program, and even if you're going to be using AI, you don't know what it's spitting out is correct or not unless you know how the basics yourself, right? That's still true. Right? What is this specific course about? It's an introduction to computer science. We use the C programming language, but it is not just a programming course. Yes, you will learn how to program in C, but you will use C as a tool to understand how to do problem solving. Right? It's computational thinking, it's algorithms, it's data structures and processing data. Making data say something that it didn't say before. Right? And at the core, what is computing? Computing is a process, and everything is a process. Biology, biological processes, they're processes, and processes are computing. Right? Business, economics, engineering, all of those things are processes, and that's exactly what computing is. It's an automation of those processes, right? As much as possible. There are some essential topics that you'll learn throughout the course, the development of this course. Of course, you'll learn how to program. You'll have exposure to software development principles and tools, data abstraction, modeling, etc. Control structures, we'll do that in the first couple of weeks here. If conditions, loops, stuff like that. And then finally, algorithms, design and analysis of algorithms, searching, sorting, and recursion. Right? We'll get to all that eventually. Don't worry. That's like 15 weeks staring at you right now. Don't get intimidated by how much there is. Right? We break it down for you, much like problem solving, into modules. Each module is roughly 1 week. For example, the first module here is an introduction, right? And each module contains several different things. It contains material and typos. I'll get rid of that later. The material consists of lectures. Every day I will update this with a link to the recording on YouTube, or you can follow along live if you want. You can even put something in chat, either anonymously. Hopefully I'll see it. Right? It's out of the corner of my eye over there. But we also have pre-prepared videos. For those of you that are already engaged and saw my messages through Canvas and CampusWire, we have a complete walkthrough video for Lab 1 and a complete walkthrough video for Hack 1, which is your first programming assignment this Thursday. We also have recommended reading. Right? We also have graded activities. We'll talk about these here in a second. And then we also have some optional reading that might help you, form a broader perspective on computing, and resources. For example, setting up your own machine if you want to, completely optional, or a Git tutorial. We'll walk you through the basics. Right? You don't need to install anything for this course. I'll show you what you can use. Right? That's Lab 1, actually. But otherwise, the modules are organized roughly 1 per week. Each module covers one major topic, introduction. Next week, the module 2 will be doing the basics. Module 3 is conditionals, loops, et cetera, et cetera. Right? Each one has pre-prepared tutorial videos. Right? All of them do. For example, if you want to start learning the basics right now, I've got videos 2.1 through 2.6. You can go ahead and start watching those and getting an idea of basic input-output programs. Right? We have graded readings, which are due Mondays. We have lectures, Mondays, Wednesdays, through Fridays, labs on Tuesdays, and hacks on Thursdays. On your schedule, it's probably just listed as lab and lab, but we call the Thursdays hacks. All right, and we'll understand each one of these in detail. Like I said, it's Monday, Wednesday through Friday, excuse me. They're all live streamed, so it's going to be on YouTube live, and it'll also be recording available afterwards. 99% of the time it works. There's that 1% of the time that it fails for whatever reason, the Wi-Fi goes out or something like that. So, be prepared, right? I would still recommend that you come here for at least the first couple of weeks. If it ever fails, we'll figure something else out. I've got 10 years of recording going back, so I might just point you to some other recording, right? My lectures are actually coded. This is the only slide deck you'll ever see in this course. I code, I do some live coding. I take some notes in Markdown. You'll see it, I write it over here. You'll see it rendered up there. And then at the end of each day or at the end of each week, I will commit it and push it out to GitHub so that you have copies of it, right? But you should still take your own notes because I'm not going to write everything down necessarily, right? I sometimes make mistakes, right? And so you should be writing down your own notes as we go along. If you want to do it on a computer, great. If you want to do it on a piece of paper, great, right? But there's also recordings. So if you miss something, you can also go back and follow along with your notes. Go to some time index, right? If nothing else, put down in your time, at 20 minutes into the lecture, he spoke about this, and I forget what it was about. Then you can jump to that time location without having to speed through the speed through the recording to find out where it is. Right? All right, those pre-prepared videos. I've got 60 of them. Right? In total, it's 9.5 hours of material. Spread that over 15 weeks, and that's like 1 hour, less than 1 hour a week that you're devoting to those pre-prepared videos. There's about 5 videos per module, right, 9 minutes each. We recommend that you watch them before class and then come to class and get another perspective, different examples. Right? It presents a different perspective, different exercises. I try to change them up every year, so even my old lectures are different examples. Watch them as review after lecture if you need to. Right? If I get a question on what is a pointer again, what I'm going to do is I'm going to post the video and a time index to where we cover that. Right? And I'm going to say, here you go. This is a great video here. Take 2 minutes to watch it. Watch it at 1.5 times speed if you want to. Campus Wire is our online help forum. If you have not accepted the invite to that, make sure that you're doing that as soon as possible, because I already had a welcome message posted last week on what you could be doing before class. And every week I post make a post at the beginning on what we're going to be doing that week. Your first assigned reading is assigned and it's due by Monday the 31st, so you have a week to do it. I have a link to it right there. Your first lab is tomorrow, Tuesday, and it's due by midnight. Your first hack, link, is Thursday, and it's due the following Monday, August 31st by midnight. Right? What are we going to be covering? Well, classes just begin. This will be more extensive as we move along. Every time we have an assignment due and it's graded, I post a retrospective on it. Here was the average score. Here are the A's, B's, C's, whatever. Right? I also say what went well, what didn't go so well, what were the common issues, et cetera, et cetera. So this is our online forum. You can post questions anonymously, privately, or open to the public, right? And you can answer other people's questions anonymously or not, right? You can take credit for it or whatever. Right? I really like having an online forum because it means that if one person asks a question, right, I answer it, you have that same question, it's answered for you already, right? Or if somebody asks it again, I'm just simply going to link back to the canonical answer, right? There you go. Somebody asked that already. You're not alone, right? You have questions. They're not dumb questions. If you think it's dumb or you think you're going to be embarrassed, post anonymously, right? Nobody's going to judge you, right? Can't judge you because you're anonymous. Already mentioned help hours there. We have 6+ learning assistants and me that hold about 20 hours per week. Again, that's in Avery 15 down in the basement, okay? Grading, that's the important thing, right? No. The important thing is learning. If you've learned something by the end of the semester, great job, regardless of what your grade is. Right? But how do we grade? Well, your grades are based on readings, labs, hacks, attendance, and exams. Let's talk about each one of those in turn. The readings are an online textbook called zyBooks. It's available through Canvas. If you go to your assignments or in any module, it's linked to immediately right here. Here's your reading there. There's your reading for next week, et cetera, et cetera. I'm going to go ahead and open it up in a new window here. It's an online textbook, right? You can load that in a new window. Okay, fine, we'll do it that way. Always go through Canvas. Don't go to their website, otherwise it won't grade you back into Canvas. Might look different. Yeah, it's going to look different for me because I'm an instructor, but some text will come up. You read some text, you do some interactive exercises or whatever. Don't know why it's taking forever, but hopefully it works better for you. And then it'll have a question at the end of each section. You answer the question, right? You get it wrong? Oh, that's all right. Answer it again, right? Reread, answer it again. Answer it as many times as you want. That's worth 15 points, right? You don't have to do it all in one sitting, right? Do half of it, come back, okay, I'm tired, I'm going to do something else. That's okay. Come back. It will update as you go along, right? Your score will be automatically updated, right? They are generally due Mondays by midnight. Obviously, I'm not going to assign something and have it due immediately done, right? So this one is due next Monday, right? There's an FAQ about this. Let's go ahead and open that up and take a look. An FAQ, frequently asked questions, right? How do I get access? Through Canvas. It will you don't have to go to the bookstore. You don't have to get a code or anything like that. Instead, they've got some new system where, unfortunately, it is charged. I think it's like $65 or something like that, somewhere close to that. But just by simply being in the class and using the book, the data will get sent over to the bookstore and you'll be charged automatically. If you drop the course, right, before the census date within the first 10 days, hopefully you don't drop the course, but if your schedule is still in flux and you drop, you won't be charged. If you are charged, just go to the bookstore and say, give me my money back. All right? How long do readings take? You should expect an average of 1 hour per week. But early readings are longer, 90 minutes, 2 hours. You can take as long as you need, right? Everybody reads at their own pace. But some of them are longer, some of them are shorter, but the average is about 1 hour. And I post those stats each time too. I got a 0. What do I do? Well, here are the instructions, right? You just need to sync it, right? Where do I get more information here? What about help? Right? They're being paid. You're paying them for the privilege of reading this book, so they're going to be giving you help, right? So you can go to their help page. There's a live chat that you can go to, etc. Right? That's zyBooks. The readings are due generally before we start covering the topics, so that you have a primer on those topics. Right? Again, it's worth 15 points, and we'll talk about points here later on. Labs are on Tuesdays. Attendance is required. We'll talk about attendance here in a second. It's 15 points. It's graded on completion. It is due the same day at midnight. They're designed to be done within that hour and 15 minutes that you have in lab, right? But if you don't get it done in lab, that's fine. You have the rest of the day until midnight to turn it in, right? It's often they're peer programming. What we'll do is if you want to work alone, that's fine, but we want you to pair up. We want one of you to be a navigator. That means that you're in charge of the handout, of dictating of where we should go next, what we should do next. Then the other one is a driver. You're in charge of the keyboard, right? You're working together intimately here. You're both responsible for communicating and solving the problem together, right? If you want to work alone, that's fine. In labs, if you want to work in 3, okay, but just make sure that you all turn in a copy because we only allow pairs. And again, it's based on completion. You complete the code, you submit it. Oh, darn it, I had a bug there. It failed. That's all right. Go back, fix it, resubmit it, fix it, resubmit it, fix it, resubmit it as many times as you want up until the due date to get those full points. Again, it is based on completion, right? So if there are like 15 tests, 14 of them pass, the last one don't, it's a 0. That's okay. Go back and fix it until you get all 15 of them, all right? And we'll talk about a submission here in a second. Hacks are on Thursday. Again, attendance required, we'll talk about that in a second. You may work in pairs, but no other collaboration. No triplets, no quadruplets, whatever else you would want to do. Don't simply just you do the first part and I'll do the second part, or you do the first week and I'll do the second week. You're shortchanging yourself in the learning there, right? A collaboration means that you are putting forth a full effort. Collaboration means actually that you're putting an extra effort, because not only are you doing the exercises, but you're also going through the communication, right? Which is great because if you pair up, then you get a second pair of eyes on stuff, right? You get a different perspective. You get some help, right? You may work alone if you want to. You can get this stuff done before before the hack or whatever, but it is due the following Monday. So it's assigned on that Thursday. All of them are open, by the way. You can start taking a look at any of them if you want to. But you have until that next Monday at midnight. So you have that Thursday. You have that Friday of help hours. You have that weekend to work on it. We don't have help hours on the weekend, though. But you can go ahead and post to Campus Wire. And then you have that following Monday, all help hours that day to get help, right? So you have 4 total days plus an online forum to get help with this, right? And it is graded based on style, documentation, design, and correctness. The correctness is auto-graded through our auto-grading system. We then come in and we grade on style, documentation, and design, right? Then we release the grades less than a week later, right? A couple days later, right? The rubric is in Canvas and in the handouts for what we'll be looking for. Each one of these hacks is 25 points. So we've got readings, 15 points, labs, 15 points, hacks, 25 points, because they're more substantial, right? And so there's more points consequently, right? Both lab and hack are required attendance, right? We give you 5 points for each day that you are there, right? But we give you the agency to decide and the responsibility to decide how you approach this course, right? So if you attend, you get those 10 points. Don't be late. Don't leave early, right? We won't give you points for that. You must work on the lab and hack for the entire time, not your calculus homework or something else, right? You must put in a full, faithful effort to get these points, right? If you attend and you do all this stuff, you get the points, no questions asked. If you don't attend, right, or you got sick, or you have something you got to go to, I don't know who are playing for away game first, but you're in the band and you have to go for pep band or whatever, right? Fine, that's fine, right? All you have to do is earn at least a 75% on the remainder of the points. Those readings, 15, labs, 15, and hacks, 25. So 55 points, whatever 75% of that is. I'm not going to do that in my head, right? We're going to go back and give you those points, whether you attended or not, right? But if you didn't get 75% and you didn't attend, that's kind of saying something. I didn't attend, I didn't put a full faithful effort, and I wasn't able to get my work done. Obviously, there's something wrong there, right? You're not going to get those points. But you have the agency and the responsibility that if you can demonstrate that you don't need to attend in order to get, a good grade, 75, like even a marginal grade, then we're going to say, all right, you don't need to attend then, right? That's our compact with you, right? Our agreement, right? So there's the attendance policy. Attend and you get the points. Don't attend, but still do well and you still get the points. By the way, that's going to be automated. I run a script to do it, so we're going to have to wait until everything's graded. You'll see a 0 initially if you didn't go. You'll get those points back eventually. Right. There's an ongoing research project associated with this course with introducing parallel and distributed computing, PDC, into this course. As far as this course goes, it's just a pre-course survey and a post-course survey, and then in between, there's a series of modules that we want you to go through. Don't worry about it right now. I'll tell you about it when it comes up. Right? These are all based on completion. So it is a survey, even though it's an exam. Right? You answer the questions on your own. Be honest. Don't look them up or anything like that, because it doesn't matter if you get them right or wrong. You're still going to get 100 points on that, or 100% on that. Right? Finally, oops, sorry. Too much scrolling. All right, there we go. Finally, exams. Unfortunately, we do live in the world of AI now. In the past, I've had open exams where it was asynchronous. You had 24 hours. It was coding. And unfortunately, we can no longer do that. Right? So what I've done now is I've changed it so that there are more exams. There's 5 exams, 4 regular exams and 1 final exam. They represent about 37.5% of your grade. Right? See the Canvas schedule. For example, your first exam is right here in where are we? There we go. Week 4 is your first exam. Now, that's going to be on Friday, September 18th. Right? If you need to, you can go ahead and look at all the assignments over here for the actual due dates. The way that it's going to work is it's going to be done in the testing center. So you might have gotten this spiel for some of your other courses that use the testing center. They're scheduled for Friday. So we have a 3-day window. Thursday, Friday, Saturday. You will go to that link when the time comes. I think you could do it right now if you want to, and schedule yourself for any 1 hour that they're open. I believe that they're open like 7 a.m. to 9 p.m. or something like that. And they're even open on Saturday. That's the 3-day window, Thursday, Friday, or Saturday. You go in, you can take 1 page of handwritten or typed notes, right? Nothing else. They won't let your computer in. They won't. The browsers that you're going to be using are locked down. You won't be able to go anywhere other than Canvas. Then you take it through Canvas. It's multiple choice, short answer. It's all automated, right? It is your responsibility to sign up for that within that 3-day time slot. I believe if you sign up on Thursday and you miss it, you can go ahead and try to get in on Friday or Saturday. So I would do it as soon as possible if I were you, right? If you do schedule yourself for that last hour available on Saturday, good luck, right? If you do not miss it, right? Because then you'll miss the exam, right? But there are 4 of them coming up, and they're all scheduled right here. Again, if you take a look at your assignments, you can see there are all the readings along with all the due dates. There are all the labs along with all the due dates, all the hacks, all the attendance. There are no due dates on those. Those are us. And then there's the exams. Again, it's going to be 17th, 18th, and 19th. I don't know why it's on the 20th there, but whatever. You have a 3-day window. They're not open on Sundays. Maybe they asked me to do that. The 29th, 30th, 31st. Okay, I don't know what's going on there. I'm going to have to take a look at that. But you have a 3-day window to sign up, right? Of course, we'll send out more information on Campus Wire as we approach one of those dates. We already mentioned collaboration, but collaboration is not mooching. If you choose to pair up for somebody in lab and hack, great, right? But do not undermine your own learning experience by letting your partner do all the work. Don't undermine your partner's experience by doing all the work for them, right? It is an equal effort. It is a great way and a great opportunity to bounce ideas off of each other, right? Often it's a great idea to get a second pair of eyes on something. You'll be sitting there staring at the code for hours, and you're missing a semicolon somewhere. You can't find it. A second pair of eyes takes a fresh look, and they immediately find it, right? Because they're coming in with it with a fresh look, a different perspective. Right? Also use it as an opportunity to branch out and network with other people, not just buddy buddies, right? All right. We do have a syllabus. Let me go ahead and go to that. Where is it? Yeah, it's in the front page here under first module here, recommended reading syllabus. There's all the policies, but short and sweet of it is no late work is accepted, and you are expected to abide by academic integrity. That means abiding by our collaboration policies, not working in groups of 3, 4, 5, or whatever, not handing out code, not accepting code, not using generative AI. Right? Now, I'm going to allow you to use generative AI in the following way. In fact, I'm going to show it to you now. There is a generative AI that I do allow you to use, right? And it's integrated into the CS50 IDE. Otherwise, you can come here to this. It's a CS50.ai, right? It is a tutor. You can ask it questions, right? You can ask it for practice problems for your exam, but it will not give you code. For example, if I say, please write my hello world program in C, right? It's not gonna give you code. Instead, it's gonna say, I'm not gonna write that program for you, but I can walk you through the process, right? If you have a question like, what is a what is a double variable in C, right? Right? There we go. It's going to answer, right? Because it's a tutor, right? It's going to give you examples. It's going to say give you an answer. You can ask follow-up questions, etc. You do have some hearts here, right? It's not just going to allow you to ask questions. It wants you to then go back and start going through the process. So if you get down your hearts here to 0, you have to wait a little while for your health to regain, right? You can ask it, when it comes to exams, I'm taking a multiple choice question exam on C. Give me a question on, conditionals, right? Doesn't matter if you spell everything and misspell anything, it's still going to understand you. Hey, there we go. Here's some code, right? What would the following code print, right? A, B, C, or D? D, right? And it's probably going to tell me, no, not quite, right? Let's walk through this, right? That's a great tutor. That is a great use of AI, right? That's what AI should be in the context of learning, right? A tutor. If you just go to Claude or Copilot and make it do all your work for you, you're not going to learn anything. Right? And when it comes time to the test, it's going to be really apparent that you didn't. Right? All right, so don't use generative AI to write your code. Make sure to stay away from cheating websites. Most cheating websites are dead because of AI now, right? Why cheat? Why pay to cheat when you can cheat for free, right? But don't cheat either way, right? Make sure that you're abiding by our code usage policy, etc. We do use on a regular basis MOS, which is a measure of software similarity. It's a plagiarism detection thing. It's much better than like plagiarism detection with English papers or something because code is a lot more structured than English. Right? So how do you succeed in this course? Don't assume anything about yourself. If you have 4 years of high school Python, great, right? You're now learning C, right, which is going to be a much more complicated language. You've already done some C in your electrical engineering courses, right? Well, okay, you might have done it to read from a pipe or read from like a sensor or something, right? But did you actually write an entire system with it, right? You're going to learn something. If you have we start with zero knowledge, right? We're starting with a basic Hello World program today, right? Even if you have more than zero knowledge, you're still going to learn something, right? It takes years to master pointers, right? So if you've done C already and maybe you understand pointers, maybe you don't, you're going to understand it by the end of the semester, right? Coding is a skill that requires practice, just like any other endeavor. Learning to play the piano or doing badminton, or I like to run, so running, right? 15, 20 years ago, I couldn't run 1 mile, but now every day I run 8 miles, right? So it takes practice, right? Compare yourself to your, by the way, I only mention that because every month we have a run with faculty on Fridays. They'll be scheduled and sent out through Bits and Bytes. So if you'd like to join us for a 5K, Bonita will be walking, so because she's hurt her knee. So a 5K run, a 5K walk, or a 5K bike. Come on out and join us, right? But otherwise, compare yourself to yourself, not to others. Right? If you're comparing yourself to that other person that has 2 years of electrical engineering and they've already done C, right? Don't do that, right? Compare yourself to yourself. Compare yourself in the 5th week to what you were in the 1st week and how much improvement you've made over that time. Compare yourself to the beginning of the semester and the end of the semester and see how much you've learned. Don't compare yourself to somebody who has had 4 years of Java in high school, right? Or maybe even has a job already and they're taking this to supplement or something, right? The point is that everyone may struggle. In fact, everyone will struggle, but everybody can succeed, right? If you take the right attitude and approach to the course. Right? All right, any questions? Otherwise, yeah, any? Oh, yeah, good, there we go. Good question. I don't know. Looks like it did already. Or was I down to 3.5 already? All right. How long does it take to regenerate a heart? Hopefully it knows about itself. The heart's on my interface. Not something you'd regenerate on a timer that I can tell you about. They're not going to tell you. Come on. Tell me. Come on. Let's see if we can piss it off. Well, okay, now it's referring to the exam question that I asked it before, right? So it's okay. Not all AI is great, right? But anyway, let me go ahead and get rid of that CS50. All right. So, any other questions? Yeah, go ahead. Oh, speed? No. I go for distance. I mean, all-time mile, maybe 740 or so, but. Oh, no. You go ahead and run on ahead, but no, I go for distance, 4,000 K a year, and around the Earth in 10 years, right? So I'm on, with respect to Strava, I'm in year 5, but I'm sure I've done it more, right? But yeah. Yep. So we're going to talk about how to get set up here in a second. Any other questions, though? Yeah. Sorry, could you speak up? It's locked. Ooh, okay. I'll take a look at that after, right? See what's going on there. All right. So anything else? Yeah.
I'm not in the campus wire.
Make sure that you're looking at your Huskers email, and then make sure that you're checking your spam folder in your Huskers email. Huskers email will be used for everything because that's the FERPA approved email. You can put another email into Canvas if you want to, but we're going to go with the Husker email there. Right?
Would I be able to get a class code instead?
No, there is no class code. Go ahead and email me, and I'll make sure that you've got. If you just enrolled today, you might not have it. All right. Okay. Yeah.
So you would recommend this class for computer engineering?
Oh yeah, absolutely. Computer engineering. Yeah, this is the class for computer engineering. Yep.
Did the attendance policy just apply to the hacks and labs? Is that for lecture?
The attendance policy. Attendance policy is not for lecture, just labs and hacks. So if you want to follow along at home, 100% on the live stream, which looks like, oh no. Well, this says it's going. Okay, yeah. It froze up over here. Again, your mileage will vary, right? Hopefully it works 99.9% of the time, right? All right. So to get set up, of course, we've got a complete walkthrough with video 1.1 on how to, that's just lab, how to get set up, get your account set up, write a program, clone from GitHub, and hand it in to Gradescope here. You will need a GitHub account. So if you go to GitHub, where was GitHub? All right, I'll just open it here. GitHub.com. I'm opening it up in a private window here so I'm not logged in. You're going to need to sign up with GitHub. Sign up with your Huskers email, and you might get some free stuff because they like students. That free stuff might only be good for a year or so, but you might get some free stuff. Who knows? But once you've done that, then you can go ahead and log into. It's basically Visual Studio Code. It's in the browser. There's nothing to install. It's all browser based. So they recommend Google Chrome. Personally, I don't recommend Google Chrome, but I always use Firefox. But you can then log in, and you'll see something that looks like, well, here, now I'm going to have to log in. You'll see something eventually that looks like this when it actually logs in. It was acting really slow earlier today. But basically, it's an IDE, an integrated development environment. Right? Once it's set up, it's going to have a bunch of files. It's going to have a terminal that you can type commands in, and then it's going to have a basic text editor that you can open up multiple files with. Right? The files will stay persistent. That means that they'll stay on your they'll stay there. Right? It auto saves. If you close out this browser, that's fine. Log back in, and your files will be there. Hopefully, I believe that if you don't log in 90 days straight, then it probably gets rid of files. So make sure that you're just logging in there every day. You can go with this is a Code Spaces instance. You can go with a regular Code Spaces instance, but I believe that they limit you to like 20 hours a month or something like that, or 20 hours a week. And if you leave it open, you burn your time really, really quickly. The CS50 IDE is unlimited amount of time for everything. That's why we're recommending that you use it. All right, so again, like I said over here, I've got a whole bunch of stuff set up already. You're going to be doing that in Lab 1. You're going to be setting up a CS1 folder with your hacks, your labs. I've got my lecture here, right? And then you can create folders, you can create files with these buttons right here. Sometimes it falls out of sync and you need to hit this refresh button right here, right? Like if you create a new file, right, it might not show up, you just hit refresh. And now I've got this is my Hello World program here. I've already written it. But what I want to do is I want to point out some basic elements to this thing, right? So this is all in green, right? A basic Hello World program in C with the author and the date right here. What do you think this is right here? It's a comment, right? A comment is ignored by the computer, right? It's just, the comments are for other humans, not for the computer. Who wrote this? Why did they write it? What is this, right? And this is in a very specific formatting called doc-style comments. We'll talk about comments more in detail later on, but that's a comment. You're going to have an author header, just like you do in English. You turn in an English paper, what do you have at the top? Your name, the course, the date, whatever else they require. We're going to require a basic description of your program, your name and the date, or your names if you worked with somebody. Yeah? What? Are you on EduRoam? Like our wireless here at UNL? Whoa. They can't be doing that. I'm not restricted. Why are you restricted? All right, I'll take a look later on, but I'll also bend ITS's ear on that. They should not be restricting that. All right. Anybody else? Everybody's restricted? What the heck? All right. GitHub status. I know that they had a global outage late last week or midweek or something like that. You can go ahead and check to see if there's some problem. All systems operational. All right, we'll have to check into that later on. Right? It is? Oh, one or two of you working, not working? All right.
I already had an account.
You had an account, though. Yeah, okay, so maybe that's the issue. No new users? Like, can you actually get to github.com? Huh.
It's just signing up that's down right now.
Okay, signing up is down.
I signed up fine just now.
Oh, you did? Okay.
So,
All right. Anyway, we'll figure it out eventually. Nobody starts a program from scratch, right? You also have libraries that you're going to be bringing in, and that's what this is. Let me go ahead and zoom in here. Can you all see in the back now? A little bit better? All right, good. Also, I prefer dark mode because it's better on your batteries, better on your equipment. But for light, I always go light mode for lecture here because it's easier for people to see. Okay. But we're going to be bringing in here two libraries. stdlib, that stands for standard. Lib stands for library, right? So you're going to be bringing in the standard library for every program that you write. Then we're going to be bringing in stdio. Again, std standard, but io is input output, right? We're going to be doing input, we're going to be doing output with the user. We're going to be printing stuff to the screen initially, and that's what that library is for. Every program has a beginning point, and your beginning point is going to be main. What the hell is this int? What the hell is this argc? This star argv? Magic for now, we'll talk about it later, right? What I'm going to do though is print in a formatted manner. That's why it's called printf. It is not printf, right? Everything in computer science that matters is case sensitive. Something that is not lowercase is something that it can't be uppercase in this case, right? It's all lowercase, right? It's not lowercase and then an uppercase f, right? It's lowercase f, okay? Then inside of that, I've provided double quotes. Inside of that is what's called a string. It's a literal piece of text that it's going to print. We all understand hello world, but what the heck is this thing? Well, first of all, that's a slash. Is it a backslash or is it a forward slash? Yeah, the way that you remember, you're reading left to right, right? Or yeah, left to right. So a guy is, suppose a guy is facing this way. Is he leaning forward or is he leaning backwards? In this case, he's leaning backwards. So this is a backslash. Right? A forward slash would look like that, and that's not the same thing. But now we've got an N after it. That's a special character that goes down to the next line. Because I can't just go down to the next line, right? In code, that would be a different line of the code. So I need to specify that this is going to go, when you print this, I also want you to go down to the next line, okay? That's called the end line character. We also have this thing at the end, which is a semicolon. Just like when you write text, right? You have a period that ends each sentence, or an exclamation point, or a question mark. We also have punctuation here in code. Your sentences, declarative sentences like this, are ended with not a period, but a semicolon. If you don't have that, it's not necessarily correct C, right? What is this? Return 0, magic for now. Don't worry about it, right? Let me go ahead and change directory. You'll be doing this in your lab as well, into my lecture 155E directory, right? And take a look around using ls, list, right? So cd is change directory, ls is to list what's in there. Well, all I see right now is this hello.c file over here and this hello.c file over here. It's just a plain text file. It's not going to run anything, right? That's not something that a computer understands. A computer, at the end of the day, only understands zeros and ones, machine language. This is not machine language, right? Way back when in the 1950s, you had to program in machine language. You had these things called punch cards. And you poked it for a 0 and you left it for a 1, right? And then you fed it into a machine. You literally programmed in binary like Isaac Asimov thought you would be doing 50 years later. No, we're not doing that. We're writing in a higher level programming language like this and then compiling it to machine code. Let me show you how to compile. GCC is going to be our compiler of choice, right? Hello.c. Right? GCC is GNU's C compiler. That's another acronym, right? Also, it's a GNU's compiler because it can actually compile more than just C, right? All right. Everything was good, and so it didn't say anything, right? Immediately went back to my command line here. In the Linux world, the Unix world, no news is good news. I didn't get any news there. That's good news. If I had missed something like a semicolon here, then I would have gotten bad news, right? Let me go ahead and bring this up. Error. I expected a semicolon at the end there. Are you sure? All right, fine. Put the semicolon back there, right? Try to compile it again, and now no news is good news. If you write code and you forget to close your double quotes there, right? Then the compiler is going to have a bad time and it's going to tell you about it. Warning, error, 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 right? Go back and fix it, recompile it, and it's all good now, right? Now over here, I don't see any change unless I hit this refresh button over here. Oh, there's a new file there, right? Let's go ahead and type ls list over here, and I see that there's this new file called a.out. It's green. If you can't see that, that's green. And there's a star beside it. That tells me that it's not a regular old file. In fact, if I tried to open this up, it'd say, this is not a text file. Are you sure you really want to open it? Yeah, open it anyway. All right. It's not going to let me do that. But I can more it down here, a.out. And it's not a text file. Fine. Hex dump. All right, a.out. There we go. There. That's what the file contains. Can you read that? No, but a machine can, right? And that's the machine code right there. Just a bunch of zeros and ones, right? Way too many zeros and ones for me to just print out hello world, but that's what it does. I can run it by going dot, and then, now once again, is that a forward slash or a backslash using that mnemonic device I just told you? It's a forward slash. He's leaning forward. A.out, and it runs, right? There's our first program. You're going to be doing that and more in tomorrow's lab. I just wanted to give you a simple introduction primer here and show you what we're going to be doing. We're going to be going through that process again on Wednesday, but in much more detail. All right? Yeah, go ahead.
Do you have to use that ID?
Nope, you can use whatever you want. This is just free, unlimited, and you don't have to install anything. Right? By the way, the course does have an FAQ. Let me just show you last thing here. The FAQ, I'll send that out later this week, but there is documents. FAQ is a frequently asked question. So if you ever have troubleshooting with the CS50 IDE, here's what you do, right? If you want alternatives, you don't want to go with that IDE, you can install VS Code on your own by following these instructions right here, right? Windows users, you're going to have to install MinGW, right? So yeah, you can use whatever the hell you want. I will see you on Wednesday. Your lab is tomorrow.